Okay, so this FRQ, like all the others, is a real one. This is one they gave on a test. I don't remember what year, but the first point I want to make about this FRQ and about any FRQ you may encounter on your test is they love to give pictures of lab setups that confuse you, that make you think, oh, I don't even know what that lab setup is. I've never seen anything like it. I won't be able to do this question. It is meant to stress you out. Don't let it work. Because one of two things happens. You look at this and you go, I don't understand this. I'm bad at chemistry. I'm not even going to try. There are those people. Or there are people who look at it and go, we never did that lab. Miss Henry sucks. What's the point? Don't let it trick you. You can do this whole entire problem without understanding what's going on here at all. Okay? So just don't fall in their trap. It's a trap. Alright, so then they tell you some things. Ethene may be prepared by the dehydration of ethanol using a catalyst. The setup for the lab is shown above, and the equation for the reaction is given below. And then they tell you that a student added a 0.2 gram sample of ethanol to a test tube using the setup shown above. The student heated the test tube with a Bunsen burner until all of the ethanol evaporated and gas generation stopped. When the reaction stopped, the volume of collected gas was 0.0854 liters at 0.822 atmospheres and 305 Kelvin. And then they tell you the vapor pressure of water at 305 Kelvin is 35.7 torr. Part A, calculate the number of moles of ethene that are actually produced in the experiment and that would be produced if it went to completion. So two parts here. Part I, we're actually calculating moles of gas. We're going to use PV equals nRT. And we need to know the pressure of the ethene, the volume, R, and then the temperature. Here's the tricky part that many people, I'm sure, forgot. If there is water vapor in the tube with the ethene, that's going to increase the pressure, and you have to take care of that by subtracting out the water pressure from the hole pressure. So they gave you the vapor pressure of water at 305 Kelvin and told you it's 35.7 torr. Does that make sense? Is water boiling at 305 Kelvin? No. Why is there water vapor then? Water evaporates even if it's not boiling, right? If you take a cup of water and lay it on that counter and leave it until May, it'll be gone. Even if you don't put it on the hot plate, even if you don't boil it, even if you don't do anything, if you just leave it sitting, water evaporates naturally over time. So that's why you have to deal with this vapor pressure of water. So 35.7 torr is your water pressure, your water vapor. Has to be converted to atmospheres. So you can subtract it from the total pressure. And you get 0.047 atmospheres of water. Your total pressure is 0.822 atmospheres minus 0.047 gives you 0.775. So I'm going to plug in numbers. Pressure, 0.775. That's just the ethene. times the volume, 0.0854 liters, equals N. My pressure is in atmosphere, so 0.0821. And my temperature is 305 Kelvin. When I solve for N, I get 0.0026 moles of ethene. So that's what was actually produced, judging by the pressure, volume, temperature. But now we're going to use stoichiometry to figure out what we should have produced. So we put in 0.2 grams of ethanol, grams to moles, we use the molar mass, which is 46.1 grams per mole, and then it's a 1-to-1 ratio. .0043. So, actual, theoretical. What you did get, what you should have gotten. Stoichiometry is usually going to give you a theoretical yield. Stoichiometry tells you if everything went perfect, this is how much you should have gotten. Okay? Part B, calculate the percent yield of ethene in the experiment. What you did get divided by what you should have gotten times 100. .5%. Questions about that? Now, as I mentioned before, if you missed one of these, but whatever answer you got you used correctly here, you would get this point. You're not double punished. So, theoretical yield, percent yield, whatever, you should always be able to at least plug some kind of numbers in there because it's just a percent. What did I get divided by what I should have gotten? That's like a free point. Okay, I meant to tell you to skip part C. I'm very sorry if you wasted a bunch of time trying to figure out what the heck they were talking about. That's next unit. So we're not going to talk about that. That's should have been skipped. Sorry. Part D. The Lewis electron dot diagram for C2H4 is shown below in the box on the left and the box on the right. Complete the Lewis electron dot diagram for C2H5OH. So each carbon has 4 valence electrons, so 8 from carbon, 6 hydrogens, 6 from oxygen. I have 20 to work with. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You can also, every line, put 2 dots like they did. I don't like to do it. It's annoying to make dots, but you can if you want. Same thing. Questions about Lewis structures? You will draw a Lewis structure. No doubt. Okay? Part E, what is the approximate value of the COH bond angle? The central atom has 2 bonds and 2 lone pairs, so it's bent. They would accept anything from like 103 to 112 for bent. There's no way for you to memorize every single bond angle. You just have to be in the range. It's like this one's like 108, but. Last one, during the dehydration experiment, ethene and unreacted ethanol passed through the tube into the water. The ethene was quantitatively collected as a gas, but the unreacted ethanol was not. Explain this observation in terms of the intermolecular forces between water and each of the gases. Polar or non-polar? Polar or non-polar? One more time. Polar or non-polar? Non-polar, right? This is not polar. It's perfectly symmetrical. No one side doesn't have more electronegativity than the other. Non-polar things, do they interact with water with strong intermolecular forces? No. So they're going to evaporate. They have low boiling points. This thing, polar or non-polar? Polar. And in water, it's going to form hydrogen bonds and have a high boiling point. That's why. Okay, speaking of water, on the test I graded, your free responses, you'll get those back tomorrow probably. Water. Everybody tell me, what's water made of? H2O. It's H2O. How many hydrogens and how many oxygens?
Hydrogen, 1 oxygen.
2 hydrogens, 1 oxygen. Right? Mm-hmm. Right? Okay, so the question where there was a calcium ion and you had to surround it with water molecules, I wasn't even upset if you didn't know which way the water molecules should go. That's fine. I mean, annoying, but fine. Not 1, not 2, but like 5 students drew water like that in AP chemistry. Okay. There are so many things wrong with that picture. 2 oxygens, 1 hydrogen. Wrong. But more than that, which atom is bigger? I would have felt less sad had I seen that. Still so very wrong. Still makes me want to tear your paper in half. But I'm going to assume that you all were having test anxiety. Your brain went H2O. You're like 2 O's. H2O's. And you accidentally drew that. I'm going to tell myself, you know that water looks like that. And I'm going to tell myself, you will never do that again. Especially not on the test that other teachers are grading and judging me.
I'm going to do that now.
Like, I wanted to go yell at Mr. Warner because that's his responsibility. But it was also mine and Chem 1A and then this class. And I'm going to tell myself it was test anxiety. Okay? Questions? You all know that this is water, right? Okay. Alright, that's it for this FRQ. Now I want to know what questions you have on homework. Let's start, and we'll just go in order. So I'm going to start with pH, pOH, and Ka and pKa. I'll work as many on this as I can, and then if I have time, we'll go on to the next one, and we'll get through them all before the week is over. But okay, so the first one. Calculate the hydroxide concentration for a solution of hydrochloric acid. Confusing, right? Hydrochloric acid is a strong acid. You put it in water and you produce hydronium and chloride. But they're asking you for hydroxide. Do you see hydroxide in that reaction? It's not there. Where's it coming from? Water, right? If there's water, there's both hydronium and hydroxide. So what you do is you say, okay, if this is 0.0545 molar, then so is this. 1-to-1 ratio. We know that Kw equals hydronium times hydroxide. Kw is a constant. We know hydronium. And we can solve for hydroxide. You also could have found the pH using this. Then found the pOH, 14 minus the pH. And then taken 10 to the negative pOH to find your hydroxide concentration. Either one works, whatever makes more sense to you. But that's number one. Questions? Comments? Yep.
Like, I get how you use KW, but I'm still confused on exactly what its significance is and what it's explaining.
It's explaining that water is hydronium and hydroxide. And it lies really far to the left because it's a really small number. But it still tells me that if I have water, I have both of those ions. And they asked me for hydroxide, which wasn't even there unless I focus on this. Questions? Okay, part number 2. Calculate the pOH for a 0.0333 molar solution of lithium hydroxide. When you're writing base reactions in water, water is a spectator. It remains unchanged on both sides. So now, if I have that this is 0.0333, then this is 0.0333, 1-to-1-to-1. I can find the pOH, negative log of that. Negative log of hydroxide concentration is the pOH. Questions? Okay, number 3 is very similar to number 1, except they ask you for the hydrogen concentration, which is actually hydronium, same thing, in a calcium hydroxide solution. So just remember that it's a 2-to-1 ratio this time for hydroxide. So this is 0.0745. This is 2 times that, because it's a 1-to-2 ratio. And then you can find hydrogen using kW. Questions? Okay. I'm not doing this one right now. Okay. Questions on number 5? It's just finding the molarity of strong acids and strong bases. Yep.
I found the molarity and then I did that. I can give the wrong answer to me, so
On which one, A or B?
on both of them.
Did you change milliliters to liters?
Yeah.
So you should have gone grams of HCl to moles of HCl
Right.
divided by 0.2 liters.
Right.
And then take the negative log of that.
Right.
And that doesn't work?
I did not get the correct answer.
Okay, let me try. HCl is 35.45 plus 136. .005 moles divided by 0.2 liters. 0.025. Negative log of that. .160.
Yeah, I had the molarity without the zero.
Oops. Question? Anything else? Okay. Number 9, methanoic acid, HCOOH, is a weak acid with a Ka of 1.6 times 10 to the negative 4. Calculate the pH of a 0.2 molar solution of methanoic acid. So, weak acids do not completely dissociate in water. So you have to deal with them in terms of equilibrium. Remember, this X is so small that it really doesn't make a difference. And you wind up with Ka, which is 1.6 times 10 to the negative 4th, equals X squared over 0.2 molar. If you find X, you found hydronium. And once you know hydronium, you can find the pH by taking the negative log of that. But weak acids depend on Kas because they don't completely dissociate. Questions? And then part B is the same, except for you have to find the molarity first by grams to moles divided by liters. Okay, that's it for today. Tomorrow I'll work the other 2 worksheets, and we'll take the test Thursday.